Hi, folks, welcome back. Today, I want to look at another paper that compares static and dynamic type systems. Now, I know that everyone has their own personal theory about which one is better and why, but the way to get knowledge is not with anecdotes. We need to construct a controlled experiment. And that's what the authors here are trying to do, and they look at one very specific scenario. They want to ask if static types help with code comprehension. Given an API that you are not familiar with and a programming task that you need to accomplish, would you be able to do it faster with a statically typed language or a dynamically typed language? That's the experiment the authors are setting up in this paper, and the results are actually somewhat surprising and counterintuitive. This is a pretty old debate with arguments on both sides. People that don't like static type systems say that they are inflexible and that for quick prototyping, they are slowed down by it. On the other hand, proponents of static type systems will argue that thinking about your types will result in cleaner and better structured programs, and also that type systems are an important form of documentation. And it is this last claim, really, that the experiment in this paper is trying to test. The two languages that the authors choose for this experiment are Java and Groovy, which is kind of a dynamically typed Java. For the experiment, the authors want to put these two languages on as much of a level playing field as possible, and that is why they are not allowing the use of an IDE with either language. They're just using a plain text editor. In my mind, this is the biggest shortcoming of this setup because you cannot separate the advantages of a static type system from the tooling that it enables, i.e., much deeper code introspection in an IDE. But let's put that aside for now and look at the experiment itself. The authors constructed two structurally identical APIs, one in Java, one in Groovy, and they were structurally identical because one was derived from the other simply by renaming. And then the experiment participants were asked to perform 5 programming tasks that used this API. The simplest one was the first one, where they simply had to return an instance of a certain class. In Java, that would look something like this. Task 2 is also pretty easy and involves identifying 3 classes. The goal of that task was to correctly instantiate a tree view. Task 3 is of medium difficulty and involves taking a tree view, constructing a graph from it, and then transforming it with a walker that traverses the graph structure. And task 4 involves adding a new node to a graph. This involves parameterizing the initializer with a new type. And finally, task 5 is to create a menu with a command inside it. Now, in all these tasks, except for the very trivial first one, it is assumed that dynamic type systems will have an inherent disadvantage. And that disadvantage mostly stems from the programmers that use the dynamic language not having adequate clues about the types of method parameters and initializers. In a static language, you can directly see that a variable of a certain type is required, whereas developers using the dynamic language only see the name of a field or a parameter. And then they have to go digging to find out what specific class might fit that. So, what were the results? The results are actually quite surprising. we see that in tasks 1, 4, and 5, Java clearly is the dominant language. But then here we see that in tasks 2 and 3, Groovy comes out ahead. And this was a result that we were not expecting. Fortunately, the authors had instrumented the text editor that they were using for this experiment to gather additional data, and they were able to then explore that data to see why they got this counterintuitive finding for these two tasks. They looked at things like how often the participants did builds and test runs, how many files they watched, and how often they switched files. And what they found was that for the two tasks where Groovy came out ahead, the Groovy developers had to do fewer file switches. And that is an interesting additional insight into how programmers behave when they're using a dynamically typed language versus a statically typed language. What this finding seems to indicate is that the users of the dynamically typed language did a lot of trial and error runs in order to figure out the types that they needed. And when they were doing so, at least in this experiment, they managed to get an understanding faster than static types would have allowed them to. So they're essentially using a trial and error code comprehension approach when using a dynamically typed language. So to conclude, this paper should highlight to us that there is no quick and simple answer to the static versus dynamic typing debate. It might very well be that dynamic type systems are faster for smaller and easier tasks. And as we saw in this experiment, where the number of classes that needed to be identified was pretty small, between 3 and 6, it seems as if static type systems will come out ahead only if the number of types being dealt with is quite high. So that was a quick look at another controlled experiment that compared static and dynamic types. I hope you enjoyed that, and I will see you next time. Thank you very much.